Now here is the next question. Find the number of non-negative integral solutions of x1 plus x2 plus x3 equal to 10 such that x1 lies between 1 and 5, x2 lies between 3 and 7 and x3 lies between 5 and 9. So if we compare this with the previous sum, here the equation is same, but the restrictions on the values of the three variables have been imposed now. So that means of course, as we know, the number of solutions will reduce than if there were no restrictions. So to solve this, once again let us try to write the different brackets pertaining to different variables. Now as we see here, the sum is equal to 10. So therefore the total number of non-negative integral solutions required is equal to nothing but the coefficient of x raised to 10 in. Now if you see, the first variable is x1 whose lowest value is 1 and the highest is 5. So therefore while writing the powers, we start off with the smallest power, that is x raised to 1 plus x raised to 2 and so on up to x raised to 5. Then multiplied by, for x2, if we consider the powers are ranging from 3 to 7, so here we will write x cube plus x raised to 4 plus so on up to x raised to 7, and multiplied by, the final bracket is for x3, for which the powers are ranging from 5 to 9. So therefore we have x raised to 5 plus x raised to 6 plus so on up to x raised to 9. Just to clarify, you may wonder how come we have taken x in all of the brackets whereas we have x1, x2 and x3. See, the reason is that we just want to know the coefficient of x raised to 10. So therefore the variable is not important. We may take all as x or all as y. So moving ahead, we have the coefficient of x raised to 10 in. Now from the first bracket, we can take x common. So that will give us x into 1 plus x square plus so on up to x raised to 4 multiplied by. From the second bracket, we can observe that x cube can be taken common. So leaving 1 plus x square and so on up to x raised to 4 inside the bracket. And finally in the last bracket, we can take x raised to 5 common, and once again leaving 1 plus x square plus x cube and x raised to 4 inside the bracket. So therefore now we have answer equal to coefficient of x raised to 10 in. Now if we collect all the x terms, x cube and x raised to 5, that gives us x raised to 9. So therefore here we have x raised to 9 multiplied by, if you observe, all rest of the brackets are exactly same. So that gives us the cube of the individual bracket. So that is nothing but 1 plus x square plus x cube plus x raised to 4 whole cube. Now if you observe, we want to find the coefficient of x raised to 10 in this entire expression, and whereas we already have the term x raised to 9 outside, so that means from the remaining bracket we just want to find out the coefficient of the x term. So we can equivalently say that it is the coefficient of x in 1 plus x square plus x cube plus x raised to 4 raised to 3. So therefore generalizing, we can write that as coefficient of x in. Now as we have seen, we just want the coefficient of x, so therefore the higher powers will never contribute to the product which results in x. So therefore we may consider an infinite series as seen earlier. So therefore the coefficient of x in, now if you see, the bracket is nothing but the binomial expansion of 1 upon 1 minus x. So therefore that gives us coefficient of x in 1 minus x whole raised to minus 3. So therefore that is equal to, now if we expand 1 minus x raised to minus 3, we have the first term as 1, then the next term is minus 3 into minus x, and after this we need not consider the terms in higher degrees of x because we just want to find the coefficient of x. So therefore just leaving the remaining terms as they are, we get 1 plus 3x plus the remaining terms. So here we find that the coefficient of x is equal to 3. So therefore the answer is nothing but 3. So there are just 3 non-negative integral solutions of the given equation.